So what's disruptive innovation? I start with this example. So familiar? Yeah? Anybody uses it? Anybody has it? How many? One? All right, we've got 2, 3, okay. Question is, when you had it, or if you knew someone who had it, did they use it? Okay, the annual sales of Britannica in 95 was about $600 million. What was the sales of Britannica in 2005, so 10 years later? To a first order of approximation, 0. 50 million bucks, you can round up or down depending on how many zeros you have in your top line or your valuation, it's mostly 0. Now the question is, what happened? What caused that to happen? Sorry? Wikipedia, what else? Google, what else? Internet in general would be the answer. Now, I'd like to posit a conjecture. It's not true. It's not the internet that killed the encyclopedia. So let's ask the question, people who have encyclopedia, what do they use it for? What's the single biggest reason they buy encyclopedia? Sorry?
Brag value.
Okay, good. What else? Brag value, yes. Kids, good. So when Britannica was in this dire straits, actually Britannica was founded by 3 Irishmen in the late 1800s, and they sold, late 1700s, and they sold it off to a company in the UK that I don't remember the name of. It was eventually sold to Chicago Tribune some 60 odd years ago. The single biggest reason for buying Britannica is kids. People buy it because they believe it'll be good for their kids. The second biggest reason people buy it is because it looks good on shelf. Truly is. Now, imagine a $1,500 parental guilt mitigation device called Britannica got replaced by another $1,500 parental guilt mitigation device, which was what?
PC.
The PC. So it actually so if it was the case that when we had Britannica, we opened it at least more than once a year, I could argue, well, it's the internet and the ability to search that made it go away. No, it was simply replaced by another device that was deemed just as good for the kids. And no, by the way, it so happens that now that we have the PC and mobile devices and internet, we in fact do some research that we never did in the first place. So you had to kind of step back a bit and examine the problem in a bit more subtlety to get to that crux, to get to the fact that it's not the internet that disrupted away encyclopedia, it's the PC that disrupted away. And here it gave us the ability to do something that we otherwise were not doing much. So if I showed you this device, people would be familiar with this. What would you normally call it? It's an ultrasound device. It sells for about $2,000, and its quality is significantly inferior to an ultrasound machine that would be used if you went to your OBGYN or any other ultrasound-based exam. So imagine a Siemens or GE or Philips going to a radiologist and say, here, I've got an inferior device for you. I've got something that actually makes your performance go less. You get to see a much worse quality image. What would happen? What if you were to position it as a higher-end stethoscope? So how many radiologists are ultrasound users globally? Ballpark, some estimate? Pick a number. Say again? In absolute numbers. So there are 1 million doctors in the US. How many of them read ultrasound? 20,000. Globally, the number is 100,000. How many people carry stethoscopes? About 70 million today. So could you upsell to the stethoscope user a low-end ultrasound? The answer is yes. So if this disrupts away something, it'll be the stethoscope, not the ultrasound machine. Okay? This was another great example of disruptive innovation. So much the way the ultrasound was, when it came out, its performance was much lower, or in some cases slightly lower than the existing ultrasound machines, but the cost was so much lower that a different segment of the market had to adopt it. Home pregnancy test is no different. When it came out, the performance was lower than the blood test available at the time, but the cost was so significantly lower and the convenience was so significantly higher that a segment of the market adopted it. Eventually, the performance went up. price remained where it was, and it's now the standard of care. Even when you go to your OBGYN, and if you suspect you're pregnant, this will be the first thing you'll do. So they were disruptive for a basic reason that when they were introduced, their performance in fact was lower than the standard. Their performance was lower than the standard. Whether it's a Honda motorcycle compared to Harley Davidson, whether it's a 3.5-inch drive compared to the 5.25-inch drive, whether it's a 1 or 2.5-inch drive compared to a 3.5-inch drive, or it's the ultrasound machine compared to the one I showed. In each of those cases, the performance in fact went down. But the cost went down so significantly that a different segment of market adopted it. Why do I say different segment? Look at laser jet printer versus inkjet printer. When inkjet printer came out, its performance was lower than the laser jet printer, but the cost was a factor of 5 lower. Who adopted it? Not the office users, but the home users. Eventually, the performance of inkjet kept going up, price remained where it was, and it eventually became a standard. Now, most offices do have an inkjet printer. Okay, there is another kind of disruptive innovation. If you look at Amazon as an example, what did they do? Would we consider Amazon disruptive? Reasonably so. I mean, they pretty much killed Barnes & Noble. They more or less they definitely killed all the independent bookshop owners, which is a sad thing, by the way. But all the big chains also had problems. What happened exactly? So, I mean, the obvious answer is, well, if you somehow do volume purchasing, you can bring a cost of goods lower, and then you can ship it, and logistics, and yeah, and blah, and do, and da. Yeah, of course, all of that is true. But what it did was it took a value chain, a supply chain of going from the writer to publisher to wholesaler to retailer to re-retailer to the consumer, took that value chain, split it apart. They deconstructed the value chain, took some intermediaries out, called the retailer, and reconfigured the value chain. That's what they did. Second, they dissociated the information from the thing. The thing was the book, and the information is what you gathered by browsing the book. They dissociated the two. Now, the information would be available to you wherever you are, and the book could travel to you at its speed. It doesn't have to be tied to a shelf space. So a massive disruption caused by taking a value chain, breaking it apart, and reconfiguring it. Because when you do that, you take some intermediary out, which means you take some value and you deliver it either back to the supplier or to the consumer. So the second type of disruption is when you can disintermediate by deconstructing a value chain and then reconstructing it. So deconstruct, disintermediate, reconstruct. A medical example of that would be teleradiology. So teleradiology means you take an image, you somehow make it digital, and somehow by doing this, the radiologist does not have to be where the machine is. The radiologist could be anywhere. How was that disruptive? Scale, absolutely right. So let's say if there's a small town, Tuscaloosa, Alabama, I can tell you some stories afterwards why I use that name and nothing else. And if you need a very rare case of a synovial sarcoma being read by a radiologist, highly unlikely you'll find him there. So rather than that disease going underdiagnosed or undiagnosed, that image could be made available to the one guy who reads the 400 cases per year of the 800 there are. The probability goes up, it'll be found. The other thing it could do is, and it was for at least a short period of time sad that some work was outsourced, but if you go into a little bit more nuance, there were US board certified radiologists in Australia, so 14 hours time zones away, that were providing readings for emergency cases at night in the United States. So that was not done because there was a massive value arbitrage. So the radiologist in Australia is not all that much less expensive compared to the US. But there was a massive skill arbitrage at a time where that skill was not available. So imagine an emergency room in Detroit or in Chicago, I'm sure a radiologist would be on the call. But imagine an emergency room in small town somewhere, that won't be the case. So these innovations they were disruptive for that reason. They were able to deconstruct the value chain. So by dissociating the radiologist from the device, you were able to deconstruct the value chain and then reconstruct it and created value in that process. So summarizing, there are two ways something can be disruptive. One, you could do something at a significantly lower cost. So the example of a home pregnancy test or a laser jet versus inkjet printer or an ultrasound machines are example of that disruption. But the initial adopting market is different from what you're currently selling to in that case. So the little ultrasound will not be bought by a radiologist. The little pregnancy test will not be bought initially by the gynecologist and so on and so forth. Second, you could do things that you couldn't do before. So like dissociating the book from the information and then based on your last 5 purchases, giving you recommendations on what you might be able to read, what you might want to read next. I'll give you an instance of one area that I have some experience in. When radiology went digital about 20 odd years ago, what did that mean? That meant the images were either produced digitally or were converted to digital form, and then they were viewed on a monitor. And then, of course, all kinds of informatics tools were available. You could analyze those images, you could create some analytics on it, so on and so forth. Very tangibly, things that happened, productivity went up, turnaround time went down from 3 days to 3 hours. And one can go through some details of why that happened, but that's not so relevant. But it's important to say that there are things you were able to do at a significantly lower cost. But there were also things you could not do before, like looking at images in 3 dimensions. Could not be done till they had to be printed. It was only after they became digital now you could say I could visualize in 3D. It changes how radiology is taught, it changes how visualization is done during surgery, and so on and so forth. So if I think outside the box now by drawing a box around it, the example of type 1 is where you're able to do things at a much lower cost. Type 2 is where you're able to do things that couldn't be done before at all. So take an instance, if you, 20 years ago or even 10 years ago, if you went to a hospital and you got an X-ray exam taken of something, what was the probability that they would first look for the film that was taken a year ago or 5 years ago, or use it for comparison? What's the probability?
0.
2 to 3%. So about 2% of the time, the film would be used and compared. So the early sellers of digital systems said, oh, perfect, I'll configure my archive so that I leave enough storage for about 5% comparison, 5% reuse of prior data. Guess what happened about a year out? The archives literally went to a screeching halt. Why? Because just because it was convenient to use the image from a past, it was being used 100% of the time. It was always clinically indicated. It was always clinically a good idea to compare the two. But it was not possible conveniently because half the times the film get lost, they get walked away, and so on and so forth. So because it was available, it was certainly used much more often. So once again, things you could do at a lower cost, couldn't do at all. The lower part, you could call it automating an existing standard of care, where the upper part would be redefining a standard of care. So it's a standard of care that you could not do before. So an example would be, maybe tongue-in-cheek, if you are ever going to have stroke, hope that you have it in Helsinki and nowhere else. Why? Somehow they managed to bring the standard of care to a point where the door to needle time is 26 minutes. The average in the US is about 4 hours. Why? So when an ambulance picks you up, if you have stroke, the ambulances are equipped with a CT device, CT machine, which is normally not the case. That data is transmitted to a radiologist somewhere on call someplace, and they make a judgment call while the person is still being transported. Is it a thrombolytes case or do I need the needle? And then, oh, by the way, they did some other subtleties as well. They had a contract with the city who would tune all the traffic lights so that this ambulance would arrive at the hospital with the least amount of disruption. That's not difficult to achieve. It just needs system to be a bit more integrated. And now you have a door to needle time of 26 minutes. Okay, so I leave that vignette and come to the notion of personalized medicine. 3 prerequisites. First is collection of large amounts of data and integrating it with the external published knowledge. So if you go to a routine practitioner, the information he or she is using was published about 20 years ago. If you go to an academic medical center, the information he or she is using was published about 10 years ago. And if you go to an icon of the field, the guy who wrote the book on sarcoma, if you go to him or her, the likelihood is the information he's using to treat you was published about 5 years ago. What about the paper that was published yesterday or a week ago or 1 year ago? Published means it has some validation that it has gone through some review process. Why should that not be brought to bear? So now the question is, how do you curate, say, 40,000 papers published on one class of oncology disease, namely gliomas, and somehow make it indexable and searchable, and combine it with the information at hand? That's a difficult task, but it's not an impossible task. It has been done in other industries. Second is you use that to create a personalized model of knowledge. And now, when it comes to medical knowledge, I'll make a very extreme statement, and I'll say the data is the knowledge. The data is the model. Any effort to abstract it, any effort to be reductionist, actually makes you lose information. How do you know that dropping, let's say if you're looking at pathology images, and if it's stained correctly, there'll be tumor cells and non-tumor cells. Conventional wisdom would say if you're going to analyze that data, suck all the tumor cells out in the image and put them in a model somewhere and says the pixel address of all tumor cells is XYZ, and the pathologist reads it. Well, because that's what we were trained to 30 years ago. There's no need to look at the non-tumor cells on the slide, generally speaking, some exception of the rule. What is to say that a year from now, the knowledge of non-tumor cells is not equally important to decide what treatment to give? So any amount of reductionism is actually really dangerous in this business because we don't know. Our knowledge models are not complete. If I was doing reductionism in paper inspection, I could be reasonably okay, that I just need to look for inadequacies or wherever the anomalies are in the paper mill, but I don't need to look at where the paper is fine. Not so the case for deducing cancer from a pathology image. And then third is applying that knowledge at the point of care. If I could portray it graphically, this is highly, highly complex. I've oversimplified. I just made a statement, don't be reductionist, and I'm now the ultimate reductionist. I've reduced it to one slide, right? But it's only to illustrate the concept. So why do I show this? I mean, if I'm unable to explain it in any more detail, why should I even show this? It's only to give the caveat, it's only to give an alert that each time you hear the word personalized, ask yourself. If you see any sign of oversimplification of reductionism, then it's just repackaged because I have to use the word personalized because the slide looks better and then my friend at some VC firm is going to look at me more seriously. I have to do it. But no, you have to go to the nuances. Now, I'm going to walk you through 10 slides. Each slide will have only 1 or 2 words. Now, these are what I consider the 10 key trends that all of this that I just talked about is going to trigger. Now, there's 2 ways to interpret the information and say, oh, fine, 10 trends. Here comes yet another book of 7 ways to kiss or 8 ways to do that or 10. No. I put some thought into it. It's not complete by any means, but I'd love some debate either later today or tomorrow because I would also like some feedback on how this thinking is. First is integration across the value chain. What do I mean by that? The example I gave of Helsinki is a perfect example of integration across the value chain. They've taken the end-to-end use case of a stroke person being found in the outskirts of Helsinki and making sure he gets thrombolytes or a needle put in his head in the amount of time that's allocated to save him or her. That's end-to-end. They looked at traffic patterns, they looked at Google Maps of traffic over the year, they figured out which routes to take at what time of the day, and they had a contract with the city that would tune, et cetera, et cetera. Another example of integration across the value chain, much simpler example, is when you review images digitally, you have to report them. Report as in, I found an evidence of scenario. It sounds like a legal document actually, but it shouldn't be. It should say, hey, you have XYD disease and you could take this dose, but that aside, this reporting, what does the doctor do today? He either dictates the report or actually somebody transcribes it. And I have seen 7 places out of 10 that take this report, go to a fax machine and fax it to the referring doctor. At the very least, I could put a fax button on that same workstation he's reporting. I mean, at the very least, why do I have to walk to a fax machine? And then I should say I should be able to do better than that. Why can't I make it available on the cloud that other guys could read based on access control and so on and so forth? So if I want to reduce the turnaround time, I should think where the result report is going at the end. Not that I did my job in this hospital in 10 hours or 10 minutes. It's got to go to somebody in the community. Second, now opposite, disintermediation of the value chain. So there are 17,000 pathologists in the US for a population of 300 million. How many pathologists are in India? Somebody venture a guess? 50,000. Who said that? 50,000. Any other guess? Take one more guess. Sorry? 800. 800, only 800. So even if I consider the 300 million who can pay, who can write a check for pretty much anything, or 100 million can really write a check for anything, 800 pathologists. So why should it not be the case that a guy whose slide is being made in New Delhi, his case is being read by somebody in Cedars-Sinai? Why should that not be the case? I mean, there's nothing wrong with creating some jobs here, right? I'm being tongue-in-cheek. Personalization of therapeutic decisions. Sounds obvious, right? So if person A has ER positive, PR positive, HER2 positive, so triple positive breast cancer, treatment should be X. And if it's a HER2 negative, ER negative, PR negative, so triple negative, it should be a different treatment, Y. That's a very simple level of personalization. I took my population and I broke into 2. How much can I further subdivide? Can I break it into N, N being the number of people? Well, probably not, because if I have sample size of 1, I don't have a reference, right? I don't have, what do I compare it to? But it should be possible to take a population and bring it to smaller and smaller cohorts so that the decision is more personalized. It's more suited, optimized for that genetic profile or that histological profile and so on and so forth. Obviously, informatics will play a key role because if I said 50,000 published paper was the last count on one disease, intermediate stage glioma, and these are 50,000 good archival standard peer-reviewed papers, I have to bring that knowledge to the point of care. Otherwise, even if this knowledge gets documented somewhere and is available to you, but in a book or even on a screen, somebody still got to read it. How do I decide at the moment of the truth, when I'm about to deliver care, I got to read that page number 7? No, it has to be embedded in my workflow. Something has to trigger me as I'm walking through my decision tree. Page 769, bring that relevant data now here. Difficult, but possible. Super specialty based delivery model. So it should be possible to concentrate knowledge where it is and care where it needs to be. So there's ample, the 10,000 hours principle, you've read all Malcolm Gladwell, by the way, to apply it to medicine, that's not new, it's been done before. There is a reason why we use the word medical practice. The more you, we're always practicing. The more you practice, the better you get. So there's ample evidence that academic medical centers that do more of certain number of surgeries have better outcomes. Sounds pretty logical. So now why can't you take that argument a bit further and say, if there's a rare disease or a not so rare disease, if I do simply more and more of that, I'll get good at it. So why shouldn't I be able to channel all my cases of a super specialty to a certain person? Integration of morphology and molecules. So this is now too specialized. Take my word for it, that's okay. You don't have to agree with it. Now, I specifically use radiology and pathology because these are two very heavily image-intensive modalities which have very large relevance to an important disease called cancer. I should say an important class of diseases called cancer. Integration across the medical record, we already spoke to that. So if you go to a typical academic medical center, it's not so unlikely to have 20 or 30 different vendors, and there's a team for integration that's always alive, and there's permanent job security. And if you ask yourself, why should integration be done at the time of design? Why shouldn't be integration done at the time of demand? So could I say search and aggregate equals integration? Search and aggregate. If yes, I could really change how integration is done. Search, how often, you are probably doing less and less of file-based organization on your PC. More often than not, you go to the search pop-up and you go look for what you need, and if you search multiple places, you can integrate on demand. That should be the case in this as well. Efficiency will remain a key driver. There's no question about it. There's still very heavy amounts of inefficiency. Informatics will emerge as a practice. That's a critical statement. So informatics is now an add-on. But people who practice informatics today are usually MDs with a computer science background or MDs who've trained themselves to be computer scientists. And then we're not looking for people who can program, and we're looking for people who can think in structures, who can think complex, large ontologies, grammars that describe a disease, a decision process, that level of work. And then education will change dramatically. What do I mean by that? So one simple way to argue that would be, well, the stuff will be taught on computers and you won't need Gray's Anatomy anymore. It'll be somewhere on a computer. All of that obviously is happening even now. A big important change in education that informatics will enable is the ability to have a transparent relationship and teamwork. Now, teamwork is yet another abused word. If you're giving a leadership talk, you got to use that word, otherwise you're not smart enough, right? No, doctors are trained to be individualists. 12 years of training trains you to be a great individualist. And now I said the ultimate antithesis, that it's becoming super and super specialized, which means multiple super specialties will have to collaborate. That's a difficult task. There are multiple reasons. Ego is one of them. It's a very strong reason. It remains a very strong reason globally. Then a culture of non-transparency. I mean, if Sarbanes-Oxley was in medicine, oh my God, okay, you can extrapolate the consequences, right? And then having that level of trust that is built out of transparency that you actually collaborate. It happens today. If you go to a physician in the room, oh, I could have bluffed my way along completely. So if you go to a tumor board, what do they do today? A tumor board has a radiation oncologist, a surgical oncologist, a medical oncologist, a radiologist, a pathologist, a social worker, probably one or two, and they actually review each case. Sometimes it takes only a minute and sometimes it takes 30 minutes. But that requires you have to be together at one place, have access to a couple of encyclopedias alongside. Question is, could you create that through an informatics model? So teamwork would be a major, major, major need in medical care. And I believe there's finally a chance that actually you enable it by, if this information is available and can be published to within certain limitations, that allows for collaboration to take place. So once again, informatics will do both. It will automate standards of care, but it'll also redefine standards of care. My two vignettes describing disruptive innovation. Now, the reason this is so complex, I use that word many times, don't reduce, don't be a reductionist. This is an automatic sign that I should stop talking? Keep going. Tap dance. Did I pull something or?
It happened before, it's not your fault. At least you said Orijit's computer, not Orijit's fault.
There you go. Almost. So the reason this is so complex is, first is the number of use cases is very large. So the possible number of things that you have to model, that you have to code, the grammar you have to construct. A use case could mean how to produce a bill for something. A use case could mean how to diagnose a very complex case of, say, a glioblastoma that requires you to integrate 5 pieces of information from 6 sources. Equally importantly, the interdependency of these use cases is very high. So n square complexity we all know of. It is amazing. If you go even 1 or 2 layers of depth, you will realize that the interdependency of these use cases, the word in medicine is comorbidity, comortality, things like that. And you can derive from it that these use cases, if use case 1 and 39 are happening simultaneously, you have to deal with it one way. If use cases 2 and 39 and 52 are happening simultaneously, you have to deal differently. So there is a non-linear dependency. Second, the number of stakeholders is very large, and that is also very highly interdependent. Third, number of variables is very large, and that's also very highly interdependent. So to decide whether I should get 68 grays of radiation or 72 grays of radiation if I have a stage 2 prostate cancer requires about 32 variables. And that's 1 class of disease, 1 subclass of cancer, 1 gender, 1 age group. It still has 32 variables. Hence, the complexity is very high. So and we don't even, it's not that if all this knowledge was published, I could say, fine, please stop creating knowledge. I'll quickly go and code everything. That's not even the case. We don't even know most of these things yet. Okay, but now I say we're at the end of the beginning. There was a 40-year-long beginning, and I do believe, given some of the things that you talked about, Mark, there's a lot of convergence. And so when that happens, going from the beginning to the real thing, you can say innovation is leading its way to a trend. So I do believe it's a disruption waiting to happen. Thank you very much.